Hello students, this is Professor here with your another video class, and today we are going to start another topic, and that is the factor theorem. Okay, and this factor theorem is just a result of a remainder theorem. Okay, so now what is the statement of this theorem? So let us first see that. So now the factor theorem states that if px is a polynomial, okay, of degree n greater than equal to 1. What do you mean by that? Means px is a name of a polynomial, any polynomial whose degree is greater than equal to 1, means either its degree is greater than 1 or it is equal to 1 but not 0. Okay, so we are not considering a zero polynomial or a constant polynomial. We are just considering a polynomial whose degree is greater than equals to 1. Okay, so that is, we are considering a polynomial greater than linear. It may be linear, quadratic, cubic, biquadratic and so on, but it cannot be a constant or zero polynomial. And a is any real number. So a can be any real number, as I already told you while doing remainder theorem also. It can be any number like half, 3/5, root 2, okay, 10, 5 and so on. Okay, then x minus a is a factor of px if and only if pa equals to 0. So now let me first remind you about a remainder theorem. So when in a remainder theorem, when px was divided by x minus a, px was divided by x minus a, then the remainder was p of a, right? So now this is just a extension of this remainder theorem. The factor theorem is just an extension of remainder theorem, as we know any number, suppose p, if I divide it by q, okay, then q will be the factor if p is perfectly divisible by q, isn't it? It implies the remainder will be 0. Okay, so for this q to be the factor of p, the remainder should be 0, isn't it? Similarly, x minus a to be the factor of px, remainder should be 0. But what is the remainder? Pa. That means pa should be 0, isn't it? So this is the condition. That means if p of a is equal to 0, then x minus a is a factor of px. But I have given the word if and only if. If and only if. This means implies and implies back. So what do you mean by that? This means this means we have this conclusion in two parts. Number one is, if x minus a is a factor, if x minus a is a factor, then pa equals to 0. And if and only if means the converse part is also true. Means if p of a is equal to 0, then x minus a is a factor from opposite sense. Okay, if pa equals to 0, then x minus a is a factor. That means from both ways. Okay, so this is a factor theorem. So let us move to the question. So we are moving to the next exercise, and in question number 1, the question is, determine which of the following polynomial has x plus 1 as a factor. So you have to see whether x plus 1 is a factor or not for the given polynomial. So number 1, what is the polynomial? For number 1, the polynomial is x cube plus x square plus x plus 1. Okay, so we can give it a name, px equals to x cube plus x square plus x plus 1, right? So now you have to see whether x plus 1 is a factor of this polynomial or not. So what will you do? You will find the remainder. You will find the remainder when px is divided by x minus 1. So in that case, what you are doing? You are finding the value of a, minus 1. So a is minus 1. So what is the remainder? The remainder is p of minus 1, right? Then what is p of minus 1 then? Therefore p of minus 1 is how much? P of minus 1 is minus 1 cube plus minus 1 square plus minus 1 plus 1, right? So this will be how much? Minus 1 cube means minus 1, because minus to the odd power is minus, so plus minus 1 square, so it will be plus 1. Why? Because minus to the even power is plus. So now this is plus into minus, minus 1, this is plus 1. Okay, so this minus 1 and plus 1 is cancelled, minus 1 and plus 1 is cancelled, so this is how much? 0. So now we are getting the remainder as 0. Okay, hence since p of minus 1 is equals to 0, x plus 1 is a factor of px, right? Okay, so this is how you will do. So now this is question number 1, and question number 2 and 3 I want you to do it as a homework. Okay, so I will do question number 4. So in question number 4, what is the polynomial? X cube minus x square minus 2 plus root 2 x plus root 2. Okay, so you have to see whether this polynomial has a factor x plus 1 or not, or if x plus 1 is a factor of this polynomial or not. So we will assume this as px. We are naming this polynomial as px. Okay, next what you will do, you will assume x plus 1 as 0 to find the value of a. So x equals to minus 1. So what is the value of a? Minus 1. Okay, so next what will you do? You will find p of minus 1. So p of minus 1 is how much? You have to put minus 1 in place of x here. So minus 1 cube minus of minus 1 square minus 2 plus root 2 into x is minus 1 plus root 2, right? So this is how much? Minus 1 cube is minus 1, as I already told you, minus this is minus square is plus, so 1 square 1. So this is this much. So minus of minus 1 means minus into minus plus. So we are opening the bracket with plus, so 2 plus root 2 plus root 2, isn't it? So this is how much? Minus 1 minus 1 minus 2 plus 2 root 2 plus root 2 2 root 2, right? So this minus 2 and plus 2 will be cancelled, so 2 root 2. So p of minus 1 is 2 root 2. So is it 0? No. Since p of minus 1 is not equals to 0, px is, sorry, x plus 1 is not a factor of px. It is not a factor because x plus 1 to be a factor of px, p of minus 1 should be equals to 0. Okay, so this is how you will do. So question number 2 and 3 I want you to do it as a homework. Okay, so now we'll move to the next number, that is number 2. So in number 2 the question is, use factor theorem to determine whether gx is a factor of px in each of the following cases. So in each of the questions 2 polynomials are given. One is px, another one is gx. Okay, so you have to see whether gx is a factor of px or not. Okay, so now in question number 1, px is what? 2x cube plus x square minus 2x minus 1, and what is gx? Equals to x plus 1 again. Okay, so now to check whether this is a factor or not, okay, you have to first assume it to be 0 to find the value of a. Let gx equals to 0 implies gx means what? X plus 1 equals to 0, so x equals to minus 1. So this is the value of a, right? So you have to find, therefore p of a, that means minus 1 equals to how much? 2 minus 1 cube plus minus 1 square minus 2 into minus 1 equals to how much? So 2 minus 1 cube is minus 1, isn't it? So minus 2 plus minus 1 square is 1, minus into minus plus 2 ones are 2, minus 1. So this minus 2 and plus 2 is cancelled, plus 1 and minus 1 are cancelled, so this is 0. So now we are getting it as 0. Since p of minus 1 is a p of minus 1 equals to 0, gx is a factor of px. Okay, so this is how you will do question number 2, and similarly question number 2 and number 3 you can do it as a homework. So we are moving to next question number 3. And in question number 3, what is the question? You have to find the value of k if x minus 1 is a factor of px in each of the following cases. Means there are 4 px, isn't it? In each case, x minus 1 is a factor. It is already given that x minus 1 is a factor. Okay, so that means x minus 1 is already a factor. You have to find the value of k in each of the questions, right? So as I already told you in the previous page that there are two conditions. If x minus a is a factor, then pa is 0. If pa is equals to 0, then x minus a is a factor. So we will use this case. X minus a is factor, that is already given, so p of a should be equals to 0. So we will find the value of a first. Okay, so let x minus 1 equals to 0 implies x equals to 1. So a is how much? 1. Since this is the factor, so p of a should be equals to 0. Since x minus 1 is a factor of px, p of a, that is p of 1 is equals to 0. P of 1 means what? P of 1 means you have to put the value of x as 1 in the given polynomial. So in question number 1, what is the polynomial? This is 3 number 1. Okay, so the polynomial is x square plus x plus k, right? So then x square plus x plus k equals to 0 implies this is how much? 1 square is 1 plus 1, that is 2 plus k equals to 0 implies k equals to minus 2. So this is how you will get the value of k. Okay, so these are the applications of factor theorem. So the factor theorem can be seen in two ways. Number 1, if x minus a is a factor, then p of a equals to 0. Number 2, if x minus p of a equals to 0, then x minus a is a factor. So in both ways you have to see and solve the problem. Okay, here x minus 1 was already given as a factor, that is why p of 1 was equals to 0, and we just replaced x by 1 and we got the value of k. Okay, in similar way you can do number 2, number 3 and number 4 as your homework. Okay, so this much for today, so we'll continue in the next video. Okay.